In this example, we are asked to find a mean or standard deviation. Suppose that the times taken for germination for cauliflower seeds are normally distributed with a mean of 7 days. Suppose also that exactly 80% of the cauliflower seeds germinate in 6 days or more. Find the standard deviation of times taken for germination for cauliflower seeds. Carry your intermediate computations to at least 4 decimal places. Round your answer to at least 2 decimal places. First, I highlighted the important information I need to identify in the wording of this question. I noticed that my data is normally distributed. I know that there is mean of 7 days. And I also know that it will take 6 or more days for exactly 80% of cauliflower seeds to germinate. This information is enough for me to get this diagram. Please notice I have a normally distributed curve centered at 7 days, that's my mean, and 6 days or more. I shade this region and I identify that this area is 80% or 0.80. Therefore, I also know that the remaining area is 20%. That is a visual representation of the given information. My question is asking me to compute the standard deviation. The only information I can think of that connects mean and standard deviation at the same place is the formula for the z-score. Z is equal to x minus mu over sigma. I'm lucky enough to be given mu of 7. I also have a specific x value from the data, which is 6 days. And I can find z-score because I'm also given the area of 80% to the right of this value of 6. So how am I going to use this information? We are going first look at the same data in a standardized format. I'm going to translate my information into the z-score world. My mean will be 0 because I'm talking about a standard normal curve. There is this unknown z-score that has 80% of data to the right of it. It is the z-score that represents 6 days in raw data format. Because I know how to find the area with the z-score, I also know how to find the z-score with a given area. I either need to use the normal CDF or inverse norm. In this case, I am given the area and I need to find the z-score corresponding to this interval. I'm going to look at it from perspective of 20%. So I want to find what is the z-score that has 80% of data to the right and 20% of data to the left. Inverse norm with area to the left of 20%, mean of 0, standard deviation of 1. These two quantities are absolutely standard for any standard normal curve. This information produces negative 0.8416 using TI-84. We are told to round to at least 4 decimal places while I'm still working on my problem, so I am rounding this to 4 decimal places. Now I have enough information to go back to this formula that connects the given data to the unknown sigma. Now I already know the z-score. I just computed it to be negative 0.8416. I know x value corresponding to the same z-score is 6. I know mu is 7. The only unknown is the sigma, and I know how to solve equations with one unknown. I replace z with negative 0.8416, x with 6, and mu with 7. Sigma is the variable I need to solve for. I notice that 6 minus 7 is negative 1, and this is looking as a proportion to me. If I write this negative 0.8416 as a fraction, proportions can be solved using cross multiplication principle, which says multiply across, and these two products should be equal to each other. So I'm multiplying negative 0.8416 with sigma to get this product, and I set it equal to the product of 1 and negative 1, which is negative 1. My next step is to get sigma alone, so I'm dividing out on both sides its coefficient of 0.8416 negative, of course. So I divide by this quantity on both sides, and this number, this coefficient of negative 0.8416 divided by itself produces a 1, and on the other side I get a positive 1.19. Sigma is all by itself on the left. So sigma, standard deviation for this population, happens to be 1.19 days.